There, folks, we're now on our next video in geometry, and specifically, we're going to talk in our chapter in circles. And in this video, we're going to talk about more on arcs, or actually, this is just still definitions of arcs. So let's have our first definition. We will always refer to this circle here for the first part. So a semicircle is an arc with a measure of 180 degrees. Its endpoints thus form a diameter of a circle. So again, a semicircle from the word semi. So it's half of a circle, literally, because that's 180 degrees. We know that a circle is the measure of the entire circle is 360 degrees. So since it's a semicircle, so therefore its endpoints lie on the diameter, the endpoints of the diameter. So we can see, as an example, we have here arc RST, or we call this as a semicircle because RST is here. RST. Okay, this is R here going this way up until T. So this is an arc, okay, which has an exact measure of 180 degrees because it's half of a circle actually, and is the endpoints R and T. If you're going to look at the chord here, it goes through the center of a circle, so therefore it's a diameter. So that's arc RST. Also, we have arc TQR, so coming from here all the way to the R. So this is arc TQR. Okay, so that's under arc, that's half of a circle still. Note that we include a third letter, specifically in the middle, to distinguish between the two semicircles with endpoints R and T. Since we can see that this is arc RT, this is also arc TR, so they're interchangeable. So we put a letter or a point in between so that we can distinguish it that these semicircles are different. Okay, so the entire circle is then the arc intercepted by one complete revolution. Okay, again, the entire circle is is then the arc intercepted by one complete revolution. So the measure of one complete revolution of a circle, again, as I've said, is 360 degrees. That's why half of 360 is 180, and that's called a semicircle. Furthermore, let's talk about minor and major arcs. So I put them in bullet form over here. So in this part of our video, we will refer to this circle here. So circle V. So a minor arc, okay, a minor arc is an arc which is smaller than a semicircle. Okay, so I have put here in bullet form smaller than a semicircle. So since we know that the semicircle's measure as an arc is 180 degrees. So since it's smaller, so therefore it should be less than, the measure of a minor arc is strictly less than 180 degrees. Okay, so also since the measure of this arc is less than 180 degrees, thus it follows that its central angle is also, the measure of its central angle is also less than 180 degrees. Again, recall that whatever the measure of an arc is the exact measure of its intercepted central angle. Okay, so one example that we can see here is arc xy. Arc xy is over here, xy. So this is the arc xy. And the measure of this arc xy is strictly less than 180 because a semicircle, it's less than a semicircle. Thus, whatever this measure of xy is the same measure with angle xvy. Okay? So that's the minor arc. That's a minor arc. Less than or smaller than a semicircle. Conversely, we also have a major arc, which is bigger than, is an arc which is bigger than a semicircle. So we have here in bullet form by definition. So it's a major arc from the word itself. So it's bigger than a semicircle. And its measure, since it's bigger than a semicircle, so its measure is strictly greater than 180 degrees. Thus, it follows that it's the measure of its central angle, which it intercepts, is also exactly the same, okay, which is greater than 180 degrees. So one example of a major arc is arc XZY. Specifically, we're putting the middle point to specify that this arc goes through Z. So we know Z is over here. So XZY, all the way to the Y. Oops, sorry. All the way to the Y. So this is our angle XZY. Okay, so um excuse my annotations. Okay, so as you can see, it's a major arc. It's more than a semicircle, half of a circle, so it's a major arc. So whatever the angle of XZ y is the measure, or rather the measure of x to zy, it's the same measure of the obtuse angle xvy in this part, in this form. Okay. Um. That's it for ambiguous situations. We will use two letters to refer for the minor arc and three letters for the major arc. Okay. So, however, this usage is not absolute. In the arc addition postulate, which we will talk about in the next video, we will show that it is still valid even if angle PR is a major arc, meaning it's only a two. There's only two letters there to represent the major arc. So angle PR is a major arc, which we will show in the next video. So thank you very much for watching. I hope that you would like and subscribe, and yeah, see you soon. Thank you.